Hey guys, so today we're going to be solving a really important problem from the 2015 AP Physics 1 exam, FRQ number 1. So basically it says two blocks are connected by a string of negligible mass that passes over massless pulleys that turn with negligible friction as shown in the figure above. So you have this scenario, no friction, and every mass is negligible except that of the blocks. The mass M2 of block 2 is greater than the mass M1 of block 1, which is obvious in the diagram, and they're both released from rest. So part A asks you to basically draw a free body diagram, but consider and draw the relative lengths of all vectors to reflect the relative magnitudes of all the forces. This is really, really important, and even if it's not mentioned in the question, try your best to make it a habit to do it either way. So for block 2, we know it's heavier than block 1. We know it has a greater mass. So let's give it like a good, all the lines. So this is your force of gravity, or mg. And then you clearly have two forces over here, mg and the force of tension by the spring. Same exact thing for block 1 because it has no reason to be different. So let's obviously tension has to be a little bit shorter than the force of gravity because here the net force is the force of gravity because of the downward motion of the block. For block 1, it's the same exact thing, but you need to make sure that your mass is relatively shorter than that of block 1, than that of block 2, because block 1 has a smaller mass. So you need to show that in your free body diagram. And then as for the tension, it's really important to show clearly that your force of tension is equal for both. So I took two lines over here. Over here you should take two lines as well. And why, you may ask? Because it's the same exact string, so it provides the same exact force for both blocks regardless of their masses. So with that, you're done with part A. Then for part B, they want you to derive the magnitude of the acceleration of block 2 and express your answer in terms of m1, m2, and gravity. So there are two ways to solve this, but I'm going to show you the best way and the easiest way to solve this. And what you should do is basically treat this entire scenario as one system. What does that mean? It means that any internal forces will be excluded and not accounted for when you're talking about net forces. So this includes tension in this case. So it minimizes the number of forces you have to deal with in terms of equations, and it's also it's basically shorter, easier, and just much more efficient, and I really, really recommend this way. So basically what you want to do is treat it as a system. So you're going to talk F net system and identify your system is equal to so what's your basically driving force and what's your resisting force? In this case, it's m2g minus m1g, because m2g is the heavier force, the longer force. So it's the driving, and then the resisting would be m1g. So you can just go ahead and take g as the greatest common factor, like that. So this is your F net system. Now you want to talk about acceleration because you want to find the acceleration of block 2. So we know the formula, or Newton's first law. So F net system again is equal to mass of the system times acceleration. So when you want to further define that, it's going to be mass of the system being m1 plus m2, as simple as that, times acceleration. And because we're not giving any values, and they even told you in terms of m1, m2, and g. They told you, by the way, lowercase m, so you might want to, stick to that, but it's okay for now. And FNet system, we already found it. Let's just substitute with this value, which is m2 minus m1 multiplied by gravity. So now, simply, since you want a, you're going to isolate a, and how you do that is by dividing by m1 plus m2, or the sum of masses, on both sides. So this will yield and give you A equals m2 minus m1 times gravity divided by m1 plus m2. Now you might say, they're asking for the acceleration of block 2, but because you treated the entire thing as a system, that means that the acceleration is uniform throughout, and any mass included in the system has the same exact acceleration. Part C and the last part of this problem says that block 3 of mass M3 is added to the system as shown below. There is no friction between block 3 and the table. Indicate whether the magnitude of the acceleration of block 2 is now larger, smaller, or the same as in the original 2-block system, and explain how you arrived at your answer. Over here, basically, we just derived the equation of acceleration, and we said that it's equal to the difference of masses multiplied by gravity and divided by the total mass of the system, which before was only two masses, M1 and M2. Now we added one extra block, and as we can tell here, this relationship, F net is equal to MA. So that means that A is equal to the force divided by the mass. So the mass and the acceleration are inversely proportional. As the mass increases, the acceleration increases, and this is the exact situation that's happening in this case. So we added a mass. Right now, your acceleration is no longer this, it's this plus M3. So it's enough to say that the acceleration of block 2 is less now because the total mass of the system increased and mass and acceleration are inversely proportional according to Newton's law. F net equals ma, and you can support it by equations by saying that acceleration is equal to force, or F net divided by mass. If this increases, this decreases. And that's basically it. So I really hope this helped, and feel free to comment and suggest topics for future videos.